So in tutorial 5, we're going to be looking at mitigation schemes. And the syllabus here refers to carbon emissions, offsetting and trading. And secondly, technology, including geoengineering. So carbon offset schemes and trading attempt to create a market value for carbon. And they try to use market mechanisms to price it. And through this pricing, they attempt to reduce emissions. So carbon offset schemes allow individuals and companies to invest in various environmental projects around the world or technologies that would reduce their emissions or balance out their emissions rather. So these offset projects tend to be in developing countries, and we're going to explore two examples here. So an individual might take a flight which produces a certain amount of carbon. So that individual can pay, so it gives a price to that production of carbon into an afforestation scheme in this case. 6 trees per passenger equals 1 round-trip flight. These trees absorb carbon, and so that balances out the emissions. It doesn't reduce the emissions, it simply balances it out. In the second example, a company here needs to meet its emissions cap, so it has a limited amount of pollution that it can create. But what it can do is it can invest in a reduction scheme. So in this case, various schemes, afforestation, we've got solar energy panels here, and various schemes here. It talks about, look, even methane capture and combustion, and we know that we've got carbon capture schemes as well. So this company invests in these schemes and is, for that, it receives carbon credits, 1 ton of greenhouse gas emission reduction. So it can offset some of the emissions it causes through the purchase of these schemes. Now, if we think about offset schemes, they have been hit by various problems. The first one has been low participation. So according to the IATA, fewer than 1% of all airline travelers actually offset their emissions. So it seems to be kind of low priority. In the first years of offset schemes, they were kind of hit by a lack of regulation or accountability and transparency around where the money was going. And so actually there was a great deal of distrust about the effectiveness of those schemes. In recent years, perhaps a consequence of climate change, there's been large-scale forest fires. So these have undermined long-term carbon offset schemes through forestry. And actually, there's a known difficulty in accurately quantifying how much carbon is actually offset through these programs. In recent years, the company Climeworks, which are a carbon capture company, have been very successful. So they have a technology to do with direct air capture. This is a very efficient way of capturing carbon. In fact, it's 2,000 times more efficient per area than afforestation schemes, and it's commercially viable. So what they can do here is they can, ambient air goes into the system, they use a filter to capture CO2, and later that, once that is saturated, that's heated to temperatures above 100 degrees C, and that creates a concentrated CO2. In fact, what Climeworks are doing is literally turning carbon into stone where it can be safely stored for the long term. So there are various carbon markets around the world, and what I'm going to do, I'm not going to go through this page. You can see it's very dense. So what I'll do is I'll just make it bigger in some places. Maybe you want to pause the video and have a read of some of these examples of national examples that we see. Also within the private sector, how Microsoft have got their own internal scheme here. Details the EU emission trading scheme, which I'm going to go into in a bit more detail there. And then down here, we can see Australia and India, and how Australia has its own national scheme, but it's also linked to the European ETS scheme. This is, I want to talk about that a little bit more. So the second example is carbon trading schemes. And a well-known example of this is the EU emissions trading system. So in this case, what we've got is we've got companies which are given a certain quota for emissions. And in this case, look, here's the quota, and this is the amount of emissions. And so there's a certain amount of unused allowance there within this one company. The second company, look, is exceeding its cap, and so can purchase the excess that's left over from this company. So you're getting a market value added here and a trade across these two things. So the EU is quite a successful system in the sense that it is functioning, it is working, it has got countries participating in it across the EU. It has achieved quite modest reductions in emissions. And I want to emphasize that point, that these are really quite modest. And that might be seen as a criticism of the ETS scheme. So the ETS has not substantially reduced emissions. That's kind of a key criticism. The ETS is used to undermine other climate and emission control policies. Perhaps you might argue that the European Union has put too much emphasis on its ETS scheme, which has had quite modest results. Perhaps not invested in other emission reducing technologies enough. The ETS kind of sets a ceiling on mitigation ambition. It reduces the allowances very modestly over time. So that kind of limits the ambition of the speed of reduction of mitigation. The EU ETS has not been cost effective. It's been heavily subsidized by taxpayers, and who's benefited, of course, big companies, big businesses, big polluters. And there is widespread belief that it's open to fraud and abuse. What has happened in recent years, if we go back to the 2008 crisis, there's been a surplus of allowance that has been allowed to build up. So allowances not being taken because of a slowdown in production and a slowdown in emissions. So this surplus has kind of affected the market price value of carbon, reducing carbon prices, actually basically making it very affordable for companies to keep polluting. So in the short term, the surplus risks undermining the functioning of the carbon market. And in the long term, it just could affect the ability of the ETS to meet more demanding emission reduction targets cost effectively. The price of the carbon being so low that companies really don't pay too much attention to it. And then finally, we've got geoengineering techniques. And I just want to make sure that we're very clear on this point down at the bottom here, that the safest and most predictable way to moderate climate change is to take early and effective action to reduce emissions. No geoengineering method can provide an easy or readily acceptable alternative solution to the problem of climate change. So there are technology solutions to mitigation, and some of them are adaptation. So what is geoengineering? Well, geoengineering is the large-scale intervention in the Earth's system to counteract human-induced climate change. And there are two basic approaches to intervention. So we've got carbon dioxide removal and solar radiation management. So some geoengineering strategies are linked to mitigation. Ocean fertilization is one of them. Look, the sprinkling of iron to stimulate growth of CO2-eating phytoplankton. You can see that this is relatively safe. It's ready to go, but it's reasonably expensive. What we see with the forestation schemes, which is another example, you can see that's very safe. And again, it's ready to go and it's quite affordable. But remember that it's been undermined by forest fires. Now, air capture, which I mentioned earlier on, is very expensive, but yet we know it's commercially viable, it's safe, and it's reasonably ready to go. It's just not scaled up enough at this stage. It needs investment. Other geoengineering are more adaptation-based, injecting aerosols, and so reflecting radiation. So we can see that here in stratospheric aerosols. They inject sulfur to reflect the sunlight, increase cloud condensation. And again, this is actually reasonably cost effective, and it's ready to go and very safe to operate on. There are some kind of really quite wild examples of desert surface albedo. So this idea of covering the desert with surfaces that reflect sheets. It's like something out of The Simpsons, this one, isn't it, really? vast areas of desert covered with these shiny sheets. It's going to be very expensive to do that. It's quite safe, of course. It's ready to go, but the spatial scale of that really is hard to fathom. And then we've got space reflectors launching mirrors into space. Again, very, very expensive solutions, not particularly ready to go. So, there are many challenges that exist with geoengineering strategies. This includes the permanence of them, the impact that it might have on the ecosystem, the disruption it has to the ecosystems itself. Some of them may cause geopolitical tensions across regions, across nations. When we start to talk about kind of airspace, this could definitely have geopolitical implications. And desert environments tend to be cross-border as well. The cost is very inhibiting at the moment for a lot of these technology solutions, and there remains a technology lag, in particular in terms of making them cost-effective or getting them ready at the right scale. Again, one thing to finally finish with, geoengineering strategies are not an alternative to the reduction of carbon emissions. And that would be quite an important point to make clear.